this video, we're going to look at something called regression to the mean, as well as different points such as outliers, influential points, and high leverage points. So regression to the mean is just another way to come up with your least squared regression line, your y hat equals a plus bx, if you don't have an individual list of data, but if rather you have just the summary statistics of your x and your y values. Now these two equations, these are on your formula sheet, and in order to get the b value that goes in for your slope of your least squared regression line, you can find that if you know the standard deviation of the y's, the standard deviation of the x's, and your correlation coefficient. So if you were to plug those three values into this little equation, that would give you your slope. Now notice that to find the y-intercept, that is based on this slope. So if you take your slope times the average of your x values and then subtract that from the average of your y values, that's how you're getting your y-intercept of your least squared regression line. Now again, both of those are on your formula sheet. So this is not something you have to memorize. They're here. And then they plug those into your least squared regression line, y hat equals a plus bx. So they're going to give you the summary statistics. You just solve the one with the b first, and then you use that to solve the y bar equation. And last, we're going to look at the difference between points that are outliers, influential, and high leverage. So first, an outlier is a point that doesn't follow the general trend, and it has a large residual. So out of these 3 points here, if you were to put in your line of best fit and find your residual, the second two would have large residuals, but the first one has a small residual. So this first one is not an outlier, but the second two are, because they have large residuals and they don't fit the trend of the data. So even though this first one doesn't fit the trend of the data, it's way far away, it's not considered an outlier because it has a small residual. Now, your influential points, those are points that if you take those points out, you would end up changing your least squared regression line pretty substantially, either the slope, the y-intercept, or the r value, the correlation coefficient. So for the first one, if we took that point out, you'd still have the same least squared regression line. For this second one, if you took this point out, your line would shift down just a little bit, but it wouldn't be a substantial change. But this last one, this is going to change your slope a lot. If you take that point out, your line will tilt further up, further away from that point. And you could play with that on your calculator or with Staplet to see what would happen there. So that means only this last one is influential, since that's the only one that's going to substantially change your least squared regression line. And the last definition is our high leverage points. Our high leverage points are just about the x values. So if you're looking for an x coordinate that has a much larger or smaller value than all the others. So you're looking for a point that horizontally is further away from the other points. So you have this guy here with this point way far on the outside, so that is high leverage. In terms of all of these points, this x value is right in the midst of them, so that one's not high leverage. And this one again is far away from all of these other x values, so that one is also high leverage. Now there is no calculator video for this section, but there are some practice problems, so make sure you try those before moving on.